Hello everyone, back again with me. This video will demonstrate how to do the increasing the performance of our design in FPGA using the data flow method. In the previous video, we already done increasing the performance using the pipeline method. Now I will demonstrate how to do another method using the data flow. Uh, in the data flow, we will using the same source code as the pipeline, which is the YUV filter. So it's same with the pipeline. Now we will compare it. In this source code, the the first configuration is the pipeline already on and the inline is off. Another configuration is that we already doing the already give this command using pragma that as a directive in C synthesize. The pragma means that we limited the loop count in here. The loop count minimum is 200, so the image size of this filter should be minimum 200 pixel and the maximum is 100 1920. This is the command that we already give in your C code. So the performance of this design is using the pipeline and already done using the loop trip count limitation. Now to do the data flow, we run first this solution using a pipeline. As always, we open the VTIS HLS and go to this directory. Now run VTIS HLS. Now running the DCL file. The DCL file name is run YUV filter dot DCL file. Already making the solution one. In this solution, we doing until the C synthesize and the C simulation already done right now. The test is passed. So right now doing the C synthesize. Okay, the synthesize already done. Let's open the project. Project name is YUV filter project. YUV filter. Okay, let's open the report, the synthesize report, to see the verse solution report. YUV filter report. And here, as you can see, that we already doing the scheduling and already done doing the pipeline. The loop is already doing the pipeline in this solution. Now let's check. Let's check the solution is using a memory in here, using a RAM, VRAM. The memory is using a VRAM right now, and the latency, the maximum latency is to 14,000, from 2 to 14,000. I'm sorry, from 2 to 14 million right now. Okay, now we will doing another solution using data flow solution, using a data flow method to optimize the design. In the solution, we create new solution. So the project, new solution, second solution. In the second solution, now active as an active solution. Now we open the source, C source YUV filter, and insert the directive. In the directive, the inline is off. It means that using the pipeline. Now we move this directive into the data flow. Using the data flow, and just press OK. Now the inline is off, and insert the data flow solution. After inserting the data flow solution, we will synthesize again using a data flow solution. Solution and synthesize active solution, because the active solution is solution 2. You can see the directive. The inline pipelining on, and the directive of data flow is on. So we are using the the pipeline and also doing the data flow solution. The second solution already synthesized. Now we will show the report of YUV synthesize. Okay. It's different from the previous solution. Now the minimum of latency is about 240,000, and the maximum latency it's still the same, the cycle. I'm sorry. And for VRAM, we use many resource of memory in the VRAM. Now I will compare it, the solution 1 and also solution 2. Compare the report between solution 2 and solution 1. This is the comparison. In the timing performance, still the same of the clock solution, estimated clock timing, but in the latency or the cycle, we do more cycle in the second solution, and for the latency we need 2.4 millisecond compared to the first solution only using 20 nanosecond. So using a data flow, but we compare the internal cycle, it's less than the second solution, the maximum interval cycle, the interval cycle. So you can see that little bit different from solution 1 and second solution. Solution 1 is the pipelining. Solution 2, we add the data flow in the solution. For the latency, the solution 1 will be better than solution 2, but the interval cycle, the second solution will be better than the solution 1. Now we will see that in the synthesize right now using the data flow compared to the first solution that without using any method, only pipeline, and we are going to do the configuration in the data flow. We going to solution setting, and in the synthesize, sorry, in the general, we move to configuration of data flow, and the default channel is ping pong, but now we going to move in the FIFO, and FIFO depth is 2. Okay, and press OK. Now in the second solution we see the directive again, is still data flow, but right now we move the solution from the PRAM into FIFO. Let's synthesize again the solution. Okay, the synthesis already finished. Now we will compare again the solution one between solution one and the second solution. Remember that we move the resource from the PRAM into Vivo. The latency and the interval cycle, it's still the same, but where we move into we move into this one, we move we see that the report show that we move from memory into the FIFO for right now. So we use all design into the FIFO resource, not into PRAM again. Into the FIFO memory procedure compared to the original memory. And we will analyze how is the data flow work. Open. Now we analyze and we move. Okay. And after that, open data flow viewer. Okay. Okay. You will see here how is the data flow configuration. You can see that we are using a different type in here. Here using CO type and in input using the memory type, and YUV using input and output. The green line you can see that you can see that we are using many pipelining in here, many flow here. bit 8-bit using the FIFO. All using a bit FIFO. Show the source. As you can see, the data flow method in here is doing for dividing the for converting the RGB to YUV and store the data into YUV scale using the FIFO buffer right now. This one, when we expand the source from the RGB to YUV here using a FIFO, how many depth and how many bit using 8-bit 8-bit data with 8 bus data to store the data from the RGB to YUV into the YUV scale process. So you can analyze how to optimize, such as how many input, how many data, or how many loops that you will design. You can see how to do the, maybe this data flow information can give you an idea how to do increasing performance. Okay, I think this is the end of the how to doing the data flow method for increasing the performance of your design in FPGA. See you into the next video.